All right, now we're on our third video with graphing logarithms. This one will be a little bit longer just because it takes a little bit longer to actually draw these graphs. All right, so let's draw our parent function of 2 to the x. All right, if you remember, our parent function has the values x and y. We're going to use -1, 1/2, 0, 1, and 1, 2. If you wanted to, you can go to 2, 4, right? Because 2 to the -1 is 1/2, 2 to the 0th is 1, 2 to the first is 2, and 2 squared is 4. All right, we can draw these. Our parent function, all right, we plot our -1, 1/2, all right, 0, 1, 1, 2, and 2, 4. Put our horizontal asymptote at y equals 0 and connect our dots and get a nice pretty exponential. All right, now the one thing to keep in mind is when we look at the inverse, any inverse of a function we can find by simply inverting our x and our y coordinates. All right, so for our inverse of our exponential 2 to the x, we're going to remember or know from last time it's going to be y is going to equal log base 2 of x. All right, we're going to get that by taking those above equations. Instead of -1, 1/2, we're going to get 1/2, -1, 1, 0, 2, 1, and 4, 2. All right, and then we can also graph this to the side like this. Okay, I went and graphed it without you guys just to save some time. All right, and some things we should talk about now are the domain and range. The first thing I want you to notice is on this logarithmic equation, we no longer have a horizontal asymptote at y equals 0. We have a vertical at x equals 0. All right, that's this equation, or this green line here, x equals 0. All right, the other things we should notice is when we deal with the exponential, right, we dealt with y is equal to 2 to the x. Our domain was all real numbers, whereas our range was limited to just the positives. However, now with our logarithmic equation, y equals log base 2 of x, these are also switched. Our domain now is just the positives from 0 to infinity, but our range is all reals. We're going to move down here to this natural log function and do kind of the exact same thing that we were doing before, right? So our exponential y equals e to the x is going to have an x and y. We're going to do -1, 1 over e, 0, 1, 1 e, and that's probably about all we're going to be able to get with this one. Right, we can graph that here, and we can also then invert that. All right, we invert that by switching our x and y's, so we're going to get y equals the natural log of x, and our x and our y's switch, so x is going to be 1 over e, y is -1, 1, 0, e, 1. Right, and then just like magic again, we can graph that here. Okay. What we're going to notice is that we can always just find our different parent functions by graphing the parent function of the exponent that corresponds with it and then inverting those values. All right, the key idea is to remember is just like with the exponentials, we're going to have a few certain points, right? With the exponents, we had 0, 1. Now we're always going to have 1, 0. Exponents, we had 1b, 1b, and now we're going to have b1. All right, and all those are going to keep corresponding. We're also always going to have a vertical asymptote at x equals 0. Some things to keep in mind is that these graphs are what we call one-to-one, which means they have inverse functions. And again, these are called logarithmic functions or logarithm functions. I have that kind of piece I talked about earlier up here. Those are some values that we're going to have. But some other things that we're going to do now is just start doing these transformations. These transformations are going to switch to sketches, kind of like they were earlier. And we have all different types of transformations we're going to get over here. And I just want to talk about what they're going to look like. All right, so this negative out in front, this is going to be a reflection over x-axis, a plus 6 here. Right, that's just like any other transformation. That'll be up 6 because it's outside the logarithm. This plus 6, however, is inside the logarithm, so it's going to be left 6. All right, this 5 out in front, that is going to be a vertical stretch by 5. Here's one that we haven't seen very much or very often, a negative inside, because this is one of the only functions that actually matters. This is going to be reflect over the y-axis. All right, and then this last one, again, one of the only functions that it matters. We have a plus 7 out here, which is up 7. All right, but then this times 2 inside is going to be a horizontal. And this is where it's weird. Since it's inside, it works opposite. So it's a horizontal compression by 1/2. So let's try one of these transformation sketches. All right, the big thing that we're going to want from these are the domain and range. All right, that's what's going to be changing. That's what's going to be helpful. All right, but when we look at this transformation, we have a -3 inside the logarithm. That corresponds with a moving right 3 units. Okay, and so what we're going to take is our parent function. So our parent function here is y equals log base 4 of x. Forgot my g. All right, again, I don't know exactly what this is going to look like, but it's going to follow the same general parent function path, which is vertical asymptote here, and then 1, 0, kind of up, and then down towards our asymptote. Now, since we're moving it right 3, we just move our right 3 spaces, right? So this x equals 0 becomes x equals 3. Our whole graph then moves 1, 2, 3 spaces to the right. And again, this is not an exact science. It just looks approximately where it's supposed to be at. But the big deal that we can do with this, what the real important thing is, our domain, which in our original parent function was 0 to infinity, is now going to be 3 to infinity because we moved right 3 spaces. Our range, because we are staying up and down, is still -infinity to infinity, all real numbers. Go ahead and try this last problem on your own. And if you want to check the answer key, it will be on Schoology. It's in the file that you're getting these videos from.